So the title of today's webinar is Get Future Ready for 2023. We think it's quite apt for our topic today, as it's going to be more of an informative webinar, what to keep your eyes on for the near future. I will be your presenter for today. I am Shuaib Yunus. I'm the Senior BIM Technical Specialist for Civil Infrastructure and Mining here at Baker Baines in South Africa. And at Baker Baines, I'm involved in numerous projects involving BIM for civil infrastructure. So at Baker Baines, we solve our customers' problems through digital transformation, helping them to design and make a better world. And if you look at this one slider of a very quick condensed snapshot of who we are and the brands that we support, you can see that we partner with a lot of cool technologies. So yeah, our three main segments or components that we focus on, the biggest one being consulting, followed by education, as well as software and hardware. And in terms of industries, we play a lot in practically all of them, but the main ones are building, civil engineering, energy, process plants, and manufacturing. All right, so now that you know a little bit about us, let's look at the agenda for today. So I'm going to start off with a quick context as to why we need digital transformation. And you'll see that when we're looking at the top 5 industry disruptors, how important this is to streamline your processes as a professional, as a company, as an organization. We're then going to look at what the future holds. And then, of course, we're going to close it off with the key takeaways as well as the Q&A. So let's look at the need for digital transformation. So currently, unfortunately, this is in certain cases still being applied, but we call it the methodology of the past, where you would normally do your design using AutoCAD. AutoCAD was the tool to take all of us from the drawing board onto the first type of digital platform. And we would normally design, export that file probably to a PDF, and then attach it to an email. Now, the problem with this, I think we've all faced this as professionals. It either gets lost in our inboxes, or it doesn't come through due to file size, or if it does come through, it's very, very basic. It does not have what we call metadata. Metadata makes a design much more intelligent. An example for that is if I had to draw a line and I had to put it on a drawing, if I did not have a text attached to it that I've inserted manually, it could be interpreted as various things. That could be a center line of a road, it could be a pipe, it could be a water pipe, it could be a plant pipe, it could be a fiber network, it could be so many different things. And metadata adds value to your actual design in conjunction with parametric modeling. So this is the methodology of the past. So in terms of today's challenges, we've narrowed this down to top 7 based on all of the clients and users that we have dealt with, both in South Africa, Africa, and abroad. The first one is, of course, increased design complexity. Things are much more complex now, especially when it comes to urbanization, population, and so on, where we cannot employ the methods of the past to solve problems that never existed then. So current practices are painful, they're manual, and very inaccurate. Design errors are very closely related to this, because if you do not design correctly and you do not foresee your challenges properly, you will capture inaccurate conditions, your design data will be off, and so on. That has a ripple effect on your project deadlines. So you're going to get a lot of variation orders, a lot of time extensions, rework, revisions, and that is just problematic on its own, because all of the pressure now switches to the construction stage, whereas it should have been dealt with in the design stage, from preliminary or inception right up to detailed or issued for construction. Collaboration is also a very big part of it. How would you integrate with a lot of multidisciplinary industries? If you're working in a consortium, how would you collaborate? How would you share your data? How would you coordinate it effectively and integrate it across your teams? And of course, transitioning. So Africa as a continent is predominantly on this 5th point, where a lot of consultants are moving from 2D to 3D. There has been an increased shift over the past 2 years. Project managers, you know that points 1 to 5 is going to make your work very, very difficult. So scheduling, forecasting, it's going to become quite a nightmare. And as a business owner, being more profitable if point 1s to 6 are occurring in your environments, being profitable is going to be very difficult. You're not going to be that economical. You're not going to be able to save, make a good ROI, retain your talent, and so on. So these were the top 7 today's challenges that we're seeing across all of our industries. So the solution that has been commonly applied is connected BIM. It's seen as the methodology of today. You'll see a lot of white papers on it, a lot of webinars on it, a lot of, I know the NBS did one in 2020. I think they also did one in 2021, where they took census from every continent besides Antarctica, and they've got the adoption of BIM, and it had increased, if I remember correctly, to 73%, or awareness as well as adoption to 73% from 11%, I think, in 2013 or 2011, one of those two. The takeaway point there is it is a force that is going to be applied, a methodology that has been seen as a winning recipe. If you don't know what connected BIM is, or if you know what BIM is and you don't know what BIM or connected BIM is, so BIM stands for Building Information Modeling, and connected BIM is with the incorporation of using cloud computing and data storage. So it's incorporation of cloud functionality, and it allows you to design, plan, build, manage your infrastructure in a much more synchronized way, much more transparent way, much more efficient way. And at the center of it all is the data. So if you have consistent data throughout your workflows, it makes facilities management, operations and maintenance, as well as digital twinning, which we're going to touch in a little bit, much more effective. So if you use the correct technologies, I want you to take a good look at this image, right? This is what we would call a base model. Unfortunately, a lot of consultants cannot even get to this as a base. This is the base model, and you could turn this with the correct technologies, processes, and methodologies to this. So before and after. So you can see the significance of this. What you're not seeing in this picture is those buildings. If you had to go into it, if they were detailed correctly, you will be able to see the architectural interiors. If there was a steel model, you would be able to see the steel beams, columns, and so on. Utilities, services, if they were below ground, you could actually go and look at that in 3D. And the beauty with metadata and parametric modeling is if you had to select any of those objects, the metadata associated to it will appear. So what diameter of pipe it is, what type of wall it is, the thickness, the height, what material, and so on. So this is what BIM enables you to do. So if you had to look at it in a much more graphical sense, this is BIM for the AEC industry, but it transcends all of the industries that you are currently working in. So you can see we can incorporate survey or terrain data, geospatial data, reality capture, scans, drones, AEC design. So whatever you're designing, whether it's road, bridges, tunnels, structures, surveys, civils, I mean, the list goes on and on. You can incorporate all of that into a central model. And the great thing with that is you can output it to a variety of different sources. Machine control is pretty popular abroad, where it's used mostly, I would say, in airport design to get the runway to millimeter accuracy, but it can be used in a lot of different applications. Mining industry actually applies this quite well. So machine control, where you can take your model, link it to an intelligent machine, and it could do the work for you. You've also got the affordability of 4D and 5D construction simulation, where 3D is the actual model, 4D when you incorporate the dimension of time, and 5D is when you incorporate the dimensions of time as well as cost. Of course, you would use your MS Projects, your Primavera, your Excel to do your program. Once you hit play, you'll have your finish to start, start to finish, your concurrent tasks, and so on. And once you have that, you can click play, and you can actually see what has been completed, what is at what completion level, and so on. Visualization is a byproduct of the intelligent process of BIM. So you can get a really crisp, realistic, cool model, and you can get that in varying levels. So visualization is quite a great thing, especially if you are project pitching and you want sign off based on a concept that you are proposing. Estimation documentation is automated, meaning it's linked to the model rather than 2D conventional workflows where you would do these sections, elevations, plan views, and so on. And those views will make up the model. Now we are using the model as a central source of truth, and we are extracting data from a dynamic parametric model. So that shift in workflow is actually revolutionary. All right, so now that you have a good understanding of them, what it is, what it can do, how it's applied, let's jump into the meat of the topic today and look at the top 5 industry disruptors. So I'm going to give you a quick fly through. The great thing with this, or the intention with this, is to show you what we currently have in industry. So what you have access to, what you could do, what is the norm based on industry trends currently, and it'll create an awareness to you. So you could probably apply it in your industry, in your consulting environment, to see how you could wield it to your advantage. So scan to BIM and drone to design is a really popular one in industry. So scan to BIM is where you use hardware like laser scanners. These can be fixed or they could be handheld. There's backpacks, there's UAVs, there's mapping units that you would fix onto like a car or something like that. And you could literally scan your environment. So scan to BIM is the term normally used in the build industry. So you would capture interiors, buildings, architectures, structural components, and so on. So scan to BIM is when you will take the hardware in conjunction with the workflow, the software, apply it, and at the end of it, you will get a point cloud of the existing structure. Drone to design is the same principle, but you would use a drone or a UAV to do this. This is used on a lot of mass projects or big sites where you would fly over, capture it, and you would create a point cloud from it. You can then extract the terrain to give you the surface elevation on site, and you can start designing accordingly. So this can be used for a multitude of things. It can be used for surveillance, it can be used for construction progress, site progress, inspections, slope stabilities, depending on how you set it up, and so on. So that is the difference between scan to BIM and drone to design. Again, scan to BIM is the term that you would normally use or hear of in the build industry, drone to design in the civil and probably mining industries. So let's look at it quickly. So here's a quick video, a quick snapshot of scan to BIM, how it will be applied for buildings. So you can see you can create different elevation sections and so on. This is a point cloud that has been captured and processed, and it has been linked into, in this case, Revit, which is a parametric tool used by architects, structural engineers, MEP professionals, and so on. And you can literally start designing from here. So you would use the point cloud as a tracing tool, and you can then model with the intelligent tools much more quickly. As you can see here, we've got like a stepped scenario around the building, and with the intelligence and automation that is being applied or provided to you by these tools, you can link it. Of course, you can also get some really cool visualization. This is the point cloud that has been overlaid with the architectural design. So it shows you what was there and what is going to be there, or what is planned to be constructed in the relative environment. So pretty cool for buildings. Now, what about plant and factories? So let's have a look, because a lot of people have the misconception that it's only for architecture, but you can use it for plant and factories. So as you can see here, we've got a base model in Autodesk InfraWorks. This was the plant or the workshop, whatever you want to call it, that was scanned. And you can see the piping and stuff like that. Now, the quality of your scan depends on your actual hardware. And here we are using the power of the cloud, or the Autodesk Construction Cloud, previously known as BIM 360, to link our projects and our teams much more efficiently. Now you can see the collaboration part of it, where we can link it with, in this case, Revit. This is where the collaboration and coordination of data is so powerful, because a lot of these tools talk to each other. You can incorporate and integrate quite seamlessly, and you do not lose intelligence. You might lose some metadata depending on translation issues if you go cross-platform, but generally, if you're working in this environment, you should be pretty good. As you can see here, this is where Plant 3D is very, very powerful, where you can use it line to pipe function in this case, or whichever tool you are comfortable with, and you can create a run depending on what you have. And you can see how intelligent it is. It will use the correct elbows, flanges, and so on based on the data that it picks up. So it's very, very intelligent. You'll have the point cloud of the actual plant, and you can model it in a much more quicker way, whereas before you would have to do it in 2D, and it's quite cumbersome. And this just shows you, you can see here, it picks up that there's a pipe, and it needs to break it apart so that that structure can fit in quite nicely. So this is where we talk about intelligence and parametric modeling. Now, when it comes to drone or drone to design, this is predominantly, like I said, used on huge sites or linear infrastructure, so roads, and it can also be applied here. So for example, maybe we are doing an upgrade, or we might have some rehab work or maintenance work. We could actually scan the site with the roads incorporated into it. Again, with the power of the cloud, it makes your life much more easier, where it serves as a single source of truth across your project. And we can do a lot of different studies with cloud computing. As you can see here, traffic mobility, simulation, point cloud geometry, linear extraction features, where the software will use its algorithm to pick up the common points and extract the edge of roads, center lines, and so on for you, with the inclusion of manual extraction, meaning you can go and define an area that you would like to extract and view it according to the cross section. There you can bring it into Civil 3D for your detailed design, and you can get the exact precise elevations that you would like. And the bonus here, of course, is the incorporation of GIS. So if you have utility data, whether it's on a data source online by a GIS professional, or they provided you with a shapefile, which you could import, both can work, and you can design much more intelligently. So if you need any clearances to be abided to, or there's certain structures or certain type of infrastructure that you need to avoid, that GIS data will allow you to do your design relative to that. And as you can see, this is a simple bridge over an existing road. And of course, you've got the automation with Dynamo. You've got generative, you've got data-driven, and you've got computational design. So generative design, now while all of these might sound very similar, which they are, they can be applied differently. So generative design is where you will incorporate different parameters based on your engineering outputs or inputs to get a desired result, desired strength, material, those type of things. And the computing power will then run its iterations for you, and it will give you options that suit or fulfill that criteria. So it'll give you multiple options. You'll have a look at it in a bit. It will give you those options, and then you can choose the one that is more realistic for you or more sensible for you. Data-driven design is where we use inputs, purely inputs, to generate the structure or our design. You will also see that, where if you adjust or edit or modify a certain parameter in your design, the other parameters then adjust accordingly to suit that edit. And last but not least is computational design. Computational design can be described as either iteration-based, meaning it will keep running computations and give you a best result, so singular, or it could be visual scripting, where again, inputs based on algorithms or input prior leading to a node will then be optimized based on your input. You can then adjust it on a visual slider or something like that, and then you can get your design done. So hope that made a bit of sense, but let's have a look at what we are talking about. So the first thing is computational site design. Right. So as you can see here, before what we had to do is create feature lines for each civil object and then grade it individually. Now we don't really have to do that. Whilst it still works, and it does work quite nicely, it is time consuming, even though it was still the fastest way to get around things. Now we have just stepped it up, where you can have your grading intent for multiple objects. So as you can see here, we have building pads, we have parking lots, and so on here. And based on your criterion, you can see that there's even a heat map on the right-hand side based on elevation and so on. And it will start running a live iteration for you. So it will start computing, you can stop it, you can optimize it, and you can send the results back to your design, and it will give you the results. Right. Another example for this is like a simple residential area, or you've got the houses, you've got the roads, and then you've got like a pond or a pool or something on the left-hand side there. It will start running its computation. You can see also the building pads or the housing platforms that have also been created based on different elevations on site, and it will give you the best suited scenario, of course, based on your engineering inputs. It also applies to bridges. So wing walls, you know, normally you put the wing walls to protect the bridge, and then you've got your stone pitching and whatever it may be for erosion control. This will also allow you to preview that. So for example, you can see those are the wing walls. You can select it as a retaining structure or defining structure, and then you will see after your design, once the computation is run, you can send it back and it will look much more realistic. So it will show that the soil is then being retained on the edges of the road. Right, so generative design is the very cool one. You'll see it here right now. So of course, we would normally design depending on what type of axis, what type of component we're doing, what is the materials types and so on. So I think the easiest thing we'll show is actually a part. So here what you would do, of course, you will model this using your normal CAD tools. Here we probably use Inventor, and you would specify your constraints, what you would look for, what your production volume will be, what configuration of axis. You can see 3, 2.5, and 5, your different options, what your cutting will be. And based on your inputs, this is what will happen. It will run its iterations, and generative design will give you all of these options to select from. So then you as the engineer or the designer will have a look at it. You will select your top, how many you would like, and then you could select the one to start designing. So from here now you can see the mesh that has been defined on the object. Now, even though this might look pretty weird or not stock standard, what it has done, it has optimized the part to use the least amount of material to achieve the desired amount of strength. Right? So engineering is like that, so that we don't get failure and over designing. So generative design is used in a lot of things to make design much more efficient, economical, and much more lightweight, if I could say that, because you're using the least amount of material and processes to achieve the desired results. So it is economical, sustainable, and much more efficient. And then, of course, you can use that part into your design, and with the intelligent modeling tools available, you can then link that to your model and it will sit in there quite nicely. Now, visual scripting is the one, I've heard this quite a bit throughout the year. It looks very complicated, and I agree, especially if you don't have a programming background or you're not used to seeing things like this on the screen. So as you can see here, we've got different nodes that are being used to position the cranes in an optimal position on a construction site. Now, a lot of these scripts you can download for online. You can go to the Dynamo website. Some are free. You can download it from the packages that are built into the software. If you search them, of course, you can modify them, check them to your liking, and then you can apply them accordingly. Now, when you do generate that, it will then run its iterations and it will move, like you will see probably the correct positioning. It can give you a visual output depending on the actual configuration of the script or of the script that you would probably apply, and then you can decide based on those outputs which one will be more effective. And this was used to optimally position these cranes on site so they are much more effective, and the criterion used here were like lift scores and so on. And as you can see, if you toggle on the graph, it will give you the different iterations, and then you can go with that. Again, making things much more efficient, not only on the design side, but also on the construction side. Now, point cloud geometry extraction technologies caused quite a stir this year. And what we mean by that is, as you've seen before, you would need to scan a building, a plant, or whatever it may be. Then you would need to process that, get a point cloud, and then start modeling manually. While you've got the correct tools, so whether you're doing plants, you're doing structures, you're doing civils, you have intelligent tools to help you do this much more better. But what if you could extract as much of the CAD for you in an intelligent manner? So that's what automated point cloud geometry extraction technologies do. So you can see here we're using normal intelligent tools to trace the point cloud out, but what if it extracted this for you? So here we've got, again, a factory type of scenario where we've scanned it, and this was the model. Now, bear in mind, it won't extract it perfectly. As you can see here, based on your density of your point cloud, this is what it will extract. The algorithm will then run and will connect the pipes for you, right? You can use this for structures, as you can see here. You can use it for building walls. You can use it for piping, as you've already seen. And this is just much more of a streamlined, or I call it the refined scan to BIM workflow, where it really optimizes your processes for you. So if you struggle on the modeling side, these technologies will assist you quite a bit. It saves you about 70 to 75% of the modeling time, because all of these objects are intelligent. So if you did a building, you can bring it into Revit and it'll come in as an intelligent Revit family. Of course, you can change it based on your family database that you probably have access to. Same for plants. You can export it to AutoCAD. Again, you would use these, it will extract as much as it can based on the quality of your scan. You can then interrogate it, make a few edits, and your model is done like 75% of it. And you've got the remainder just to do your touch-ups and your checks. So quite nicely following it is 3D printing and modular construction. So very closely related. So I've just got, I think, one example here, but this is a bridge that was 3D printed in Amsterdam. And just check this out. So that steel bridge was done as like a concept or like a prototype where they wanted to try and see how they could push it. It is a steel bridge, and you can see it has been 3D printed or fabricated in a workshop, right? So here we've got the design that was done, whichever software you would like, probably generative design in this case. A lot of different tests were run using the computational engines that are available to select the best fit or the best type of output. Then you've got robots here that are actually creating this for you. Again, 3D printing can be a variety of different things, but robots are generally used, especially in factories. And yeah, this was created quite nicely. So yeah, if you haven't checked it out, definitely see it. It's the way to go. You're actually seeing like schools being fully 3D printed or modularly constructed, put onto a flatbed, and then just literally dropped on site, done. So there's a lot of different things that 3D printing modular construction is changing. Then we've got design simulation and visualization. Now, design analysis, I think, is quite self-explanatory. Depending on what you're designing, you need to run an analytical computation on it to see if it will pass or fail. This is an example of wind loading or pressure on a shell structure on a building, where it will heat map the pressure on the elements by kPa or whatever unit of measure you're using, and it will give you which portion of the building or the structure is experiencing the most type of pressure. Also, depending on what type of materials you use on the design, whether it will pass, fail, and so on. And then you can make an informed decision. We've got clash detection in 5D construction simulation. This one excites a lot of people when they do see it. We have seen quite a few consultants apply it, which is quite great. And this is where you would incorporate a lot of the disciplines into one model. So you will append a model, and let's say if you're working on a factory or on a development, you'll have civil, structural, mechanical, electrical, plumbing, architecture, all of these design disciplines working together. And to see that everyone's work or everyone's design sits in quite nicely, we run a clash detection. As you can see here, based on this layout, this machinery shouldn't be there because there's a column that is in that place. So we would need to move it. Maybe it's a fixed type of arm, which is mostly the case. And you can run a lot of these clash detections. This is where you can also run the 5D or the timeliner. So this at the bottom is your construction program that has been imported and linked to your model. And it has your start date, your end date, your total costs, your weeks, as you can see here, same like a Gantt chart. And once you hit play, it will start simulating how this will happen. So as you go along, it'll show you, okay, this is how things are going to be constructed based on your construction program. So it's pretty cool. It helps you to do a lot. And then of course, quantification is pretty easy. It's model based, so you will get the desired output. So visualization and animation, again, this is just a pin drop at what you're seeing of what we can get now. I mean, there's augmented reality, there's virtual reality. You can get up to 8K or more rendering, very realistic. You can get simulations, you can get mobility simulations where it incorporates not only traffic, but also pedestrians and so on. You can see the conflict points or the traffic zones also can be defined based on your holding times on your lanes. And this is what I was talking about, like crowd management and so on. Again, these are all available using an intelligent workflow, BIM technologies, and so on. And you can actually simulate things like this. Now, augmented reality is my favorite thing this year. I don't know about you, but let me show you what this means, because people get confused between virtual reality and augmented reality. Now, what you're seeing here is the design printed out on a hard paper. You will get a certain type of app that will give you a QR or something like that to scan. And then you can actually impose it on your drawing or just look at it like that, where they did this model and you can see, you can actually scale it up, scale it down, look at it. So if you know Iron Man, basically what he does with the screens, and he has things in like looking at it in his hand, grabs it, makes it bigger, smaller, and so on. That is augmented reality. And this is available. I think this app used was Torch, but there are a lot of different apps. Some are free, some you'll have to pay for, some you can try on trial, but definitely play around with it. It's really, really cool. Imagine being able to see your structure like that. So the last thing here is digital twinning and prototyping. So again, these two are very closely linked, but how I define it is digital twinning is the replica or the virtual real breathing asset of a collective. So like a smart city, smart urban area or region where a lot of different components feed into like a dashboard or something like that. So it's a collective to create a digital twin, whereas a prototype can be applied to an individual component, machine, or something like that. So let's have a look. So digital twinning, this is what we are talking about. It's not a model. It's not only the model. Remember, BIM is seen as the best way to serve as the foundational requirement for digital twinning. So you'll have your 3D model with your metadata, intelligence, locations, and so on. And as you can see from there, we would need IoT 4IR to make it a digital twin. Now you can see here, for example, we can isolate components based on the models, the structures, whether it's piping, structural equipment, electrical, and then you can also monitor like the pipe temperature, what's flowing at the pipe. It's used for preventative maintenance rather than reactive. It has all of the metadata housed in here. And then digital prototyping, the Amsterdam 3D printed bridge is the best example I could say. So it's just this bridge in that area currently. So it's a prototype, or it's the first of its kind. You can see people are jumping on it. We've got sensors that have been hooked up, and it'll give you a live reading as to what is happening. And then the node points, you can always go and hover over it. You can see it gives you the temperature over the day. And this is what we're talking about, 3D printing or modular construction. It was literally printed, it was put onto a flatbed and taken to sites, assembled there, and that is it. I really feel that this is what's going to change us quite a bit in how we do things. So what does the future hold? Okay, so let's have a look at the first one. In no particular order, of course. It's living building material, or we call them LBMs. I will explain these shortly. We see cybersecurity at the epicenter of digital strategy. Construction data will justify its value, and we'll tell you why we put that there in shortly. And then autonomy being the norm. Right, so those are the top four based on the research we've done, what we've seen even the past year. These four things really came to mind. Now let us unpack these quite quickly. So let's start off with LBMs, right? So living building materials. So if you haven't heard of it, a living building material, it utilizes microorganisms to produce construction materials that exhibit mechanical and biological properties. So living building materials, definitely keep your eye on it. You'll probably see a lot of it, a lot of research or white papers or people talking about it in the near future. The next one is cybersecurity and digital strategy. So digital transformation, I think everyone has heard that buzzword, that trend over the past 2-3 years. And it's great to see a lot of people start their digital transformation journey. Cybersecurity, with the regulations that are coming out, the securities, cloud technologies, sensitivity of data, those type of things. Cybersecurity, especially on a large scale, is going to become, I would say, mandatory, in a sense that if you're working on a certain level or certain grade of project, how they would define this, I'm not quite certain yet. There are a few scenarios that I can think of, but there will be certain tiers of projects where you would need to have like a cybersecurity implementation plan or something like that. If you're not familiar with what cybersecurity is, it's the application of technologies, processes, protecting systems, networks, programs, devices, and like to curb and mitigate cyber attacks, right? Because with the acceleration of technology and so on like that, data has become king, basically. Now this one, the reason why we put this in is construction data will justify its value. We've seen a lot of users that have been using parametric modeling, digital transformation, BIM technologies, reality capture, like a whole plethora of different technologies, but they still do not see the value of it. Now, those that are in facilities management, operations and maintenance, digital twinning, and so on, already realize this. But why do we say it will justify its value? It's because based on mass data, analytics, computings, AI, dashboards, and so on, you will be able to optimize a lot of things that have been quite excessive. And last but not least, autonomy. I think everyone is pretty clued up with this one, but it will become the norm. Now we're seeing it grow quite a bit in the construction industry, where things are going fully autonomous already, construction sites. But I mean, it's affecting all of us. You're going to have self-driving cars soon, but there's a lot of things that autonomy or AI computing is built into, that things are going to be done with you just being there to like overview or oversee. Great thing with this, I mean, safety. You can do a lot of things that put human life in danger using autonomy, with, of course, the human being the overseer, the approver, and checking it. So autonomy definitely is going to be a norm. And I think from all of these, autonomy is the one that I think everyone is familiar with on this webinar. So these are the top future trends. Definitely keep your eye on it. I think it's definitely going to change the way we do things. And these are very 4 critical pillars that are going to change and, well, going to be the new disruptors, if I would call it that. Right, so in closing, I will leave you with this picture. So construction innovation, again, across everything needs to be constructed, right? So don't just think of a civil site. Everything that you design needs to be constructed. And with BIM, 4IR, digital twinning, the disruptors you've seen, currently the future disruptors, this is going to be our world. I mean, it's already there. I think more on the design front, on an asset front, it's just going to grow in leaps and bounds. So we want you to see where you are on your digital journey. So based on the industry that you're in, so if you're in the AEC industry, so architecture, engineering, construction, or if you're mining, or if you are in the product design, manufacturing, the PEM space, process plant, and so on, we've got 2 QR codes that we would like you to scan. And this will help you to see where you are. So if you want to reach out to us, there are all of our handles. We are very vocal on social media. So our website is bakervans.com. You can reach us on LinkedIn, Facebook, Twitter, Instagram, as well as YouTube. So thank you, everyone. Keep well and catch you again next year.